Okay, let's continue with our work. We will do problems from 15.3. This section is longer than the previous section. With the time I have left, I don't think I can do all of them. So you will see that I break this into two parts here. Let's call this, in my supplemental video, I will call this 15.3a then. When I continue on the next day, I will call this 15.3b. I may just continue after you leave. That's okay. I may just continue and finish this up so that the video actually intact, you know. Okay, let me start then. But again, feel free to interrupt me if you need to. Okay, yeah, especially when I make a mistake. Now, number six, we have integral from 0 to 1, integral from 0 to e to the v of square root of 1 plus e to the v dw dv. Seems like I cannot avoid but use substitution, huh? So u equals to 1 plus e to the v. Oh no, it has no v in there, huh? I mean, it has no w. What am I doing? No, this question is actually on the easier side because you see, when I need to integrate with respect to w, there's no w in there, right? So it's basically integral from 0 to 1, square root of 1 plus e to the v. Let me slow down a little bit. When I integrate with respect to w, there will be integral, there will be w from 0 to e to the v dv. Is it right? Okay. Which, if you think about it, this will give you the length of this interval, right? That will give you the length of that interval. Let me mark with different color. This guy here will be basically this guy, and later on will be e to the v. Oh, I thought that's actually on the harder side, but it's actually on the easier side, dv. Now this is when I need to do substitution. Let's say I use y equals to 1 plus e to the v, so dy equals to e to the v dv. So now this is my dy, right? This will be my y. What happened to the limit of integration? Y0 will be 1 plus e to the 0, that's 2. Y at 1 will be 1 plus e to the 1, or 1 plus e only. So this integral will then be integral from 2 to 1 plus e of y to the 1/2 dy, which will be 2 over 3 e to the, y to the 3/2 from 2 to 1 plus e. This is 2/3. 1 plus e to the power of 3/2 minus 2 to the power of 3/2. I do expect it to simplify a little bit though. This is 2 over 3 times 1 plus e square root of 1 plus e minus 2 square root of 2. Okay, that's for number 6. Oh, I was expecting that to be a lot harder. Number 8, we have double integral over domain D of y over x to the 5th plus 1 dA, where the D is, the x is 0 to 1, the y is 0 to x squared. So the y depends on x, huh? Let's sketch the graph. The x is from 0 to 1, and then the y is from 0 to x squared. So the domain of integration is actually like this. Okay, now remember, because the domain is not a rectangle, we cannot use Fubini's theorem. Okay, we cannot use Fubini's theorem because the domain is not a rectangle. this will be integral from 0 to 1, integral from 0 to x squared of y over x to the 5th plus 1 dy dx. Integrate respect to y, that will give us 1/2 y squared, 1/2 1 over x to the 5th plus 1 times y squared from 0 to x squared dx. That will be integral from 0 to 1. Let me pull the 1/2 out. When I replace the y by x squared, I get x to the 4th. Right? Another substitution, x to the 5th plus 1. Call that u. So du will be 5x to the 4th dx. And the limit of integration, u0 is 1 and u1 is 2. So this is 1/2 times 1/5 integral from 1 to 2 of du over u. I want you to pay attention, this guy. This is my du over 5. My du over 5. Okay, as for the limit of integration, the 0 to 1 becomes 1 to 2. Okay? Then I go on with the integral. I think at this point it's easy already. That's 1/10 natural log of 2 minus natural log of 1. But natural log of 1 is just 0. So this is the final answer. Any questions so far? No question? Let's go on. Number 16. Set up integrated integrals for both orders of integration, then evaluate the double integral using the easier order and explain why. Okay, so I think the issue here is not about, it's first about setting up. You need to know how to set it up. Second, of those two options, which option is easier to do? First, let's sketch the graph for the domain of integration. Okay, the x is equals to 0, that's the y-axis. Oops. And then y equals to 4. Y equals to 4. So if this is x-axis, this is the y-axis. This is y equals to 4. That's it. And then y equals to x. This is y equals to x. Okay, so the domain of integration is this triangle here. Okay. How do we set it up? So the first option is the y is from 0 to 4 and x will be from 0 to y of y squared e to the xy dx. Take a look on how we set up the double integral. Okay, so we choose 1y, right? So because the y is from 0 to 4, right? Now you choose a y and then you move in the x direction. And you notice that we get into that domain when x equals to 0 and we get out at x equals to y. Okay? Now you can think of this as the following. This is x equals to 0, this is x equals to y, because for that integral, for the inner integral in this case, the variable of integration is x. Now, is this easy to integrate? That's another story. Okay, that's another story. let's focus on the setup for now. The other option is if we do integral from of the x that's from 0 to 4, right? That's for the dx. And the y will be, imagine if I move, you pick an x and you shoot in the positive y direction, okay, you will enter at y equals to x and you get out at y equals to 4. Okay, now so these two integrals supposed to give us the same result, right? But one of them may be easier, the other one may be harder. We don't know. Which one do you think is easier? Let's try the first one. I think I will do the first one because of the following. To integrate this e, I cannot avoid but doing substitution anyway, right? Okay, and if you can do the substitution faster, it'll be a lot nicer, of course, right? So u equals to xy, du equals to y dx. Okay, and then the limit of integration, u0 will be 0, uy will be y squared. So now the integral will be 0 to 4, integral from 0 to y squared, y e to the u du dy. How do you do that, Thomas? I see this. Let me rewrite it first then. Let me rewrite it first. I rewrite this as integral from 0 to y times e to the xy, y dx dy. I hope now you can see that my du is this, right? Okay, this is my u, okay, and then this is what happened to the limits of the integral. Okay, so we now have integral from 0 to 4, integral from 0 to y squared, y e to the u du dy. And then I go on. This will be integral of e to the u du is e to the u itself. So integral from 0 to 4 y e to the u from 0 to y squared dy. That will be integral from 0 to 4 y times e to the y squared minus e to the 1, e to the 0 is 1, like this. Let me continue here. This is integral from 0 to 4 y e to the y squared dy minus integral from 0 to 4 of y dy. Okay. I do another substitution called that w equals to y squared. So dw will be 2y dy. Okay, w at 0, that's 0, w at 4, that's 16. So my double integral now becomes integral from 0 to 16 e to the w dw over 2 minus, the second integral is just straightforward, that's 1/2 y squared from 0 to 4. So that's 1/2 e to the 16 minus 16 17 over 2. Any questions so far? Thomas, can you try to do the second one, the second method? No, I don't want to. I think it will be very hard. Yeah, because this basically means I need to do integration by parts, right? Which it will be a longer work. Okay. And I think another reason why I don't want to do the second part, because we prefer something from zero. Okay, we prefer something from zero. That's for number 16. Any question? Yeah. From this point, you see the importance of observing the order of integrations. That's actually one of the technique. Okay, sometimes both ways are okay. Sometimes one of them is easier. So if you get stuck in one order, try to think another way. Okay. Now coming back to this number 16, Thomas, you have two options. Why do you choose the first one and not the second one? I think my answer is more about that. We prefer to start from constant or to start from zero. It's not always true though, don't get me wrong. It's not always true. It's just by intuition. I try to have less variable and more zeros in my domain of integration. Okay, if you ask me how do you know that the first one is easier than second one, first answer is like the first one I integrate, the second one I think it's harder because I need to do a long integration by parts. Okay, another reason is because both of them are not rectangles. One of them has variable. Okay, this one also variable. So from the variable point of view, they are basically the same. However, this is zeros here and this is 4 instead. So I try the first one first. Okay. Now, of course, then integration becomes super difficult for you if you don't even know how to do it. Right? In that case, whatever the order doesn't matter. You still cannot do that, right? Okay. So in between, I go over these problems. At the same time, you review your integrations. Okay. That's for number 16. Let's go on. Number 18. Number 18, we have double integral over domain D of x squared plus 2y dA, where the D is bounded by y equals to x. Sketch the domain right away, and y equals to x cubed in the first quadrant. So the graph is supposed to look like this, right? But we just need the one in the first quadrant. Okay, we just need the one in the first quadrant. Now, if we put more details, you will see the intersection here is x equals to 1, right? Okay, and if I pick any x between 0 to 1, it will go into the domain from x cubed and get out from x squared. So the x will be from 0 to 1. The y will be from x cubed to x, not x squared. I'm sorry, I said it wrong. So x squared plus 2y. Okay, now then when I integrate with respect to y, I will get x squared y plus y squared from x cubed to x dx. Substitute the y's. This is x cubed plus x squared minus x to the 5th plus x to the 6th dx. Oh, okay. This is polynomial from 0 to 1, so it will be just the coefficients, huh? So that will be 1/4 plus 1/3 minus 1/6 plus 1/7. Okay, that's 7/12 minus 13/42. 3, 4, 6, 7. Oh, what is that? 42 times 2, 84. The LCD is 84. So that's 23/84. That's just the algebra, right? Okay, arithmetic instead. That's for number 18. Any questions so far? From here on, I hope you see that just as just routine. The difficult part is actually how to set up the integral. Okay, that's the hard part. Okay, that's the hard part. Now, once you are able to set it up correctly, then the computation actually just a routine there. Okay, so when you do problems, focus on how to set up the integrals. Number 20, double integral over domain D of xy squared dA, where the D is enclosed by x equals to 0. X equals to 0 is the y-axis, and x equals to square root of 1 minus y squared. Well, x equals to, but this is basically means x squared equals to 1 minus y squared. That's x squared plus y squared equals to 1. But implicitly, the x has to be at least 0, right? It means we are dealing with this part. It's equation of a unit circle, but only for x non-negative. Okay, so this is the region. Okay, how do we do this? You know what? I think I will do the axis from 0 to 1. The y will be from negative square root of 1 minus x squared to square root of 1 minus x squared x y squared dy. Is it a good idea? Yeah, I think I will do it this way. Now, then you notice that the domain, the y has a symmetric interval around 0, right? Okay, and the y parts there's only one terms. It is an even function with respect to y. So what I think I will do is I double it by symmetry. Okay, and this is equal to, do I really want to do it this way? So now our domain looks like this. This is what our domain looks like, right? Okay. In Calc 2, you learn polar integration. Okay, polar integration. So it will be integral from 0 to 1 for the radius. For the theta will be from 0 to pi over 2. RD theta. D theta from 0 to pi over 2. The radius is from 0 to 1. The x is r cosine theta. the y is r squared. The y squared is r squared sine squared theta. Okay, if I put them together, this will be 2 times integral from 0 to pi over 2 integral from 0 to 1 of r to the fourth cosine theta sine squared theta dr d theta. Now you may wonder why, Thomas, you change it into polar. Because if you think about it, all of a sudden we get quote-unquote rectangular domain. Hold on, I kind of confused a little bit. Did you learn this in Calc 2? No, huh? Double integral. You don't learn double integral in Calc 2, huh? So I cannot teach you this yet then. Well, at least now you will see that it's doable. We can do it this way. But let me backtrack a little bit. I cannot teach you this yet. My bad. Then I need to integrate that as usual. 2/3 integral from 0 to 1 x times y cubed, huh? So y cubed from 0 to square root of 1 minus x squared dx. Replace the y cubed by 2 over 3 integral from 0 to 1 x times 1 minus x squared to the power of 3 halves dx. Think about this. And then from here I will do substitution. So let u equals to 1 minus x squared. So du will be negative 2x dx. So x dx will be replaced by du over negative 2. So x dx, this is du over negative 2. How about the limits of integrations? U at 0, that's 1. U at 1 is 0. Yeah, let me come back here. So the integrations now becomes 2 over 3 integral from 1 to 0 of u to the power of 3 halves du over negative 2. That will be 1/3 integral from 0 to 1 u to the power of 3 halves du. I absorb the negative by reversing the limits of integrations. Okay, so I get 1/3 times 2/5 u to the power of 3 halves, but from 0 to 1, that's it. So that's 2 over 15. That's the answer. Okay, that's for number 20. I kind of like confused. I'm sorry. I kind of confused earlier if you have learned double integrals and we convert that to polar. Then I realized no, in Calc 2 you only learn single integral. We learn multiple integral in Calc 3. My bad. Yeah. But if you if once we learn double integrals using polar, then you should be able to see that once we convert that, we'll get the same thing. Okay, let's go on. Number 24. Now, why this part is harder? Because you need to be able to see what the shape look like. So it's actually quite challenging. Number 24. Find the volume of the given solid if you have surface C equals to 1 plus x squared plus C equals to 1 plus x squared y squared. So let's say this is the curve. This is the surface. Okay, that's the surface. It's actually look like, I think it looks like this, maybe. Okay, and then above the region bounded by this. So x equals to y squared. This is x equals to y squared. and x equals to 4. So this is the domain of integration. Okay, that's for number 24. If we call this our d, then our volume equals to double integral over d of 1 plus x squared y squared dA. Is that right? So that part is easy, I think. But how about the domain of integration? I think that's the harder part. Either you want to see it this way or you see it this way. This is your x-axis and this is your y-axis. You see? Okay. I think I will do the second one. Okay, so the y will be from -2 to 2. Is it right? You said it's equal. So to find the boundary, x equals to y squared equals to 4. So y equals to plus minus 2. Right? So this is when y equals to 2. This is when y equals to -2. Let me do that one. So -2 to 2. And then for the dy, for x, that will be from y squared to 4. Is this easier? I don't know. Another option is we do this double integral from 0 to 4, and then for the dx, as for the y, that will be from negative square root of x to square root of x, like that. Okay, so this guy here should give us the same result with this. But which one do you think is easier to work? I honestly don't know. I honestly don't know. The way I think is the following. This one, if I integrate with respect to x, let's see what happens. Let's integral from -2 to 2. We cannot do symmetry yet. We cannot do symmetry because we have y here inside, in the inner integral. Okay, integrate with respect to x, that will give me x plus 1/3 x cubed y squared from y squared to 4 dy. So this will be integral from -2 to 2, 4 plus 64 over 3y squared minus y squared plus 1/3 y to the 8 dy. I think from here you can just proceed yourself, right? Oh, you know what? All the terms inside are even function, so I can double it. So this is 2 times integral from 0 to 2. Okay, so I have 4 and then plus 61 over 3y squared minus 1/3 y to the 8th dy. 4y plus 61 over 9y cubed minus 1 over 27y to the 9th from 0 to 2. 2 times 8 plus 61 times 8 over 9 minus 512 over 27. I don't know how to do that. It's too hard for me. Okay, unless I make miscomputation, I don't think so. Yeah, you can try to compute it from here. Supposed to get the same result. Okay, we're supposed to get the same result. You tried it though. Yeah, you tried it. You try this. I think it's quite doable. You try this and compare to my answers. Okay, if you get different answers, then please come back to me. You check your work first though, in case yours is the one wrong. Okay, but there's a chance, of course, that I make miscomputation somewhere here. I'm seeing if I make any mistakes. Any mistakes here must be a silly mistake. Okay, that's for number 24. I think I wanted to do number 28 also in 5 minutes. I have only 5 minutes left. But this one is good. So let me see how to do, how do I find a space to work on that. Bounded by the planes, z equals to x. Let me copy that. Number 28, z equals to x, y equals to x, x plus y equals to 2, and z equals to 0. Z equals to 0 is just the xy plane. Wow, this is quite difficult. Y equals to x, so it's this plane here. Z equals to x is this plane here. Oh, it's kind of hard to see now, huh? And x plus y equals to 2. Ooh, you know what? Let's do it this way. Let's do it this way. Let's catch x and y. So x plus y equals to 2. Y equals to x is this. X plus y equals to 2 is this. Z equals to x and z equals to 0. I cannot really imagine, is the domain this part or this part though? I'm sorry. So I have the issue here. If this is the z-axis, this is the x-axis, and this is the y-axis, the plane will come up this way. Oh, yeah, then it will be this part. It will be this part. Yeah, it will be this part here. Oh, well, why? What is the reason you choose that one and not this one, Thomas? Not this one. Well, because they don't tell us the boundary y equals to 0. Right? Yeah. So this will be the domain. Okay. So how do we set that up? They meet at 1 here. Let me just do it fast. So the domain, as for the domain, it will be double integral from 0 to 1. The lower bound is y equals to x. The upper bound will be y equals to 2 minus x. And it goes to c equals to x. So the integrand is this. That's what it looks like. Yeah, that's the setup. Okay. To integrate that, that's integral from 0 to 1. That's xy from x to 2 minus x dx. It's integral from 0 to 1 x times 2 minus x dx. That is integral from 0 to 1. That's 2x minus 2x squared, dx. So if I integrate that, that will be 1 minus 2/3. That's 1/3. That's for number 28. You know what? Let me just skip number 30 because I want to go to this change of order of integrations. The key is number 44. The key is you need to be able to sketch the domain of integration first. Okay, x will be from 0 to 2. The y will be from x squared to y equals to 4. That's the domain of integration. So if we reverse the order of integration, that will be double integral. The inner integral is dx, the outer integral is dy. Y will be moving from what to what? Y will be moving from 0 to 4, and x will be moving from 0 to square root of y. Okay, that's for number 44. Number 48, x will be from 0 to 1, and the y will be from arctangent of x to square root of to y equals to pi over 4. Very similar, Very similar questions. This is y equals to, let me give myself more space. This is y equals to arctangent of x, which means if we solve for x, we get x equals to tangent y, right? Okay, so for number 48, the double integral will be from 0 to pi over 4, from 0 to tangent y. Okay, fx y dx dy. That's for number 48. No, the last one, let me do number 52, and I'll leave number 54 with you. Sketch the domain first. Okay, x will be from 0 to 1, right? X will be from 0 to 1, and the y will be from y equals to x to y equals to 1. So if we reverse the order of integration, that will be dy in the outside, dx in the inside, right? Okay, and the y will be from 0 to 1, dx will be from 0 to y. Now keep in mind that when it comes to the limits of integration, this variable here, the dx, tells us x is from 0 to x to what? Okay, keep that in mind. Now then, how do we integrate that? You can use substitution if you want. U equals to x over y, so du equals to 1 over y dx. So dx equals to y du. Integral from 0 to 1. Integral when x equals to 0, u is 0. When x equals to y, u is 1. Okay, this is e to the u. Dx is y du dx. Oh, you know what? That's integral from 0 to 1. When you integrate respect to u, that's e to the u from 0 to 1 dx. That's integral from 0 to 1 y of e to the 1 minus e to the 0. I'm sorry, this should be y here. Should not be x. Okay, so this is e minus 1 times 1/2, right? Over 2. That's for number 52. Let me give you the sketch for number 54. Okay, the y will be from 0 to 8, and x will be from x equals to cube root of y, which means the graph is the same to y equals to x cubed, to x equals to 2. So it refers to this one here. If we reverse the order of integration, then the outer integral dx will be from 0 to 2. The inner integral dy will be from 0 to x cubed of e to the x to the 4th. Oh, I think this one is on the easier side because the integrand has no y. When we integrate with respect to y, that will be just the length of that interval. And then from here I do substitution. Which means du over 4 will substitute x cubed dx. As for the limits of integration, that will be from 0 to 2 to the 4 is what? 16? E to the u du over 4. So there will be 1/4 e to the 16 minus 1. Oh, it's not hard to do, huh? Okay, this is where I will stop our 15.3.